That's very weird. Okay, I'll take a look. Okay. So. All right, so let's get this started, okay? So I'm gonna go ahead and share my screen. And what I'm gonna do is I'm gonna go ahead and show you, I'm just gonna talk briefly about Runestone. So I've graded chapters, I've ran the grader at least once for chapters 3 and up through chapter 4. Also, I apologize. I didn't realize I didn't put the links up for the chapter 5 and chapter 6 record exercises and the like. I should have done that earlier, and I apologize for that. I'm sorry. So that may impact what we decide to do later. Okay. Or that may impact what we decide to do today, since you might not have had a chance to do things other than watch the videos that were already posted. Okay. So if you need more time on these things, let me know. Again,
Professor,
these are soft due dates. Yes.
where can we find the assignments list?
You can find the assignments by, if you go on the Canvas, right? First off, there's 2 ways to get there. First, if you're on our textbook page on Runestone, you just hit the person icon up here in the top right, hit assignments, and it'll bring it to you, and it will list everything on Runestone, including the quizzes that has currently been assigned. The other thing to do, okay, is that if you're working from Canvas, you can go over here to, oh, come on, really? You can plug it in. What's going on here? I've been talking like I've been talking to thin air the entire time. Great. All right. So like I said, assignments listed here, top left, sorry, top right. Click on this, brings you to here. Okay. That brings you to the assignment page. You can also get that way by going to the current module, which is module 4, and clicking and okay, where's that? I don't know. Okay, there's the other one. Why is that one not available? I'll have to check that out. Give me. Oh boy, what is going on here? Why does it say that's not available? Did I remove it? I don't think I removed it.
It's available for me.
Weird. Maybe it's just my computer being silly. Okay, weird. All right, chapter 5, chapter 6. Right, if you click on those links, it will bring you to this page. Make sense? It'll bring you to this page that has the due dates for everything listed. Again, for everything but the quizzes, the due dates are soft. Okay. Yes. As in the what? They're a sub-selection. They're not all of the exercises. So if you happen to do all of them, you'll have done the ones that I care about, but the exercises are a subsection. So like chapter 5 exercises, right? It's not all of the exercises. It's the ones that I thought were interesting. A lot of them are for this one are dragging and dropping the code to make sure we manipulate the turtle correctly. So let's see. So anyway, I've run the grader on these. As a result, you may have noticed that like you may have gotten some question, some button like score me has disappeared, or you're unable to update your own grade after reading it. Don't worry about that. That just happens when I run the grader. That's what happens when I run the grader. So when I run the grader next time, if you've done the readings or the like, and that should happen later this week. If you've done the readings or caught up on the readings, it will catch you. The grader just makes the score me button disappear because it doesn't. The system assumes that basically I'm not going to be running the grader more than once. That's kind of the idea. The idea is that you run the grader and it's done. And that I'm not accepting late homework, right? But here the idea is that I can keep running this thing again and again, no problem. So you'll notice that it won't have a score me on there, but if you run it again, it will pop up. Also, right, if you haven't been able to figure it out, right, if the code block is if you don't see a coding block right over here, just hit the show code and it will pop up. Okay. All right. So now with regards to the quiz, if you had any issues with the quiz, such as I had one student who wasn't able to take that because there was a medical emergency, okay, just let me know. Okay, but otherwise, right, if you turned in the quiz late, let me know so that I can go and manually check it, because if you've turned it in past the due date, the late penalty for that quiz applies, right? If you miss the quiz, it's not good. It is going to be the one that is worth the least. So keep that in mind. And I also will be dropping one of the quizzes. So, but the quizzes do have a hard deadline. Now, I noticed also there was a 45, I put in the 45-minute, but I didn't realize it would automatically submit. I thought it would just keep track. So the other ones won't have an explicit countdown time limit, so you can take as long as you need on them. Okay, that was my bad. I didn't realize that it was doing that. I figured that out by creating a quiz that lasted for 1 minute. So yes, somebody in chat is now entering. Is the grade we see on the quiz for the assignment page, the actual grade? It should be. It is at least your preliminary grade at the very least. If you've got a 34 out of 34, you're probably going to be happy with that, and because 34 points was the maximum. Now, here's what the next step is. The auto grader graded it. I didn't. I made the auto grader as good as possible for my questions. Okay, but I can't foresee every eventuality. There's one of the most common mistakes I saw with students was, if we open up Notepad for just a second, was when you did the equation, it was what, p plus 1, p plus 1, blah, blah, blah. It doesn't really matter. But the math equation was p times an equation in parentheses. So the most common mistake was that students forgot that in Python and in calculators in general, you have to have an explicit multiplication there. Okay. That was the most common mistake. It will have given, the auto grader will give you a 0, but I am not nearly as punishing as that, but that's because it's a syntax error. It has no idea what's going on. Whereas it's very obvious to me what's going on, and that's like a 1-point mistake. So what the next thing is I'll send out an announcement both here and on Discord with a Google form. You just simply put in your name and tell me what the question is that you need me to look at again, and I'll manually regrade that question, or all of them if you need me to. It just helps me speed up because now I don't have to check over 160 people's worth of exams, right? The autograder gets pretty much everything correct, but not the case for everybody. It's just the process. If you think it's an onerous process, let me know, okay? Because I don't want to make it too onerous. So, but I will look at your grade because you probably didn't do nearly as badly as you thought you did. Okay. So going on to module 4. What page is what? This page, this is chapter 2 exercises. Right now I'm going on to module 4. So module 4, I initially had thought, let's do an exercise today about creating random passwords. But given the fact that I put the readings up pretty late yesterday, so you haven't necessarily had a chance to look at them. It was either yesterday or something. I don't know. Given the chance I had forgotten to put up the readings, I think I'll delay this for Thursday, and I'll explain more in detail about basically this giant blob of information that's coming your way, because you are about to be hit with a whole lot of topics that you've been exposed to, plus some that you've been using kind of intuitively, but not fully appreciating. Okay, so that's what we'll probably do today. So chapter 5 goes into more depth about turtles and how to use them. Now, exercise 3 is using turtles with a bit more explicit behaviors, like do a for loop, create the rings of the Olympics, those kind of behaviors. But chapter 4, we use for loops, and we do it gets a bit more complex, I think, because we're going to be using functions as well. So So as a result, this homework, lab 4, notice that it says lab 4 plus 5. So this will be the focus of not just this week's lab, but of next week's lab too. So this assignment is essentially is almost completely 2 assignments worth. It is 180 points rather than your standard 100 points. Okay, it's almost 2 assignments. As a result, it's not going to be one of the ones I drop. I do drop some lab assignments. It's not going to be one of the ones I drop because it's worth so much and it's so integral to you understanding this point. So this is probably the most important link. I will also be posting a second quiz that goes over turtles and for loops. Just turtles and for loops. It won't cover lists at all. Okay, just turtles and for loops. A lot of exercises that are going to be on there are going to be comparable to the, and I'll go over this again. They're going to be comparable to these exercises, which is arrange the code so that it does we form the figure over here, right? That's one of the questions I'll typically ask. Like, can you please arrange the code to draw this figure? Or another one I'll ask is, I have this, here's figure A, here's figure B. Please complete the code I have to draw figure A is what we have now in the code. Please complete the code to give me figure B. Make sense? It's all going to be turtle. It's going to be experimental. And not experimental. It's going to be interactive, so you'll be able to figure that out. But again, I'll be posting that. There's no need to really be panicky about that. Now, I had mentioned something about doing quizzes in person in classes, you know, in our quizzes, and I have checked in with my TAs who have all reported that is a resoundingly bad idea because of all the students who are not attending, who are saying they can't attend lab because they are tested positive for COVID over the weekend or something like that. Like, or they came into contact with, generally it's not that they tested positive because we'd be getting alerts, but that they came into contact with somebody who had tested positive. That's generally what happens. And then they, out of abundance of caution, which is awesome, stay home. Okay. So because of that, I think I'll just stick with the online quizzes that I've been doing for the past 2 semesters for right now. Okay. Until that otherwise changes. If need be, I will probably make a quiz worth, the quiz point values range from like 100 points to, so from like, as you've seen, 34 points to about 100 points. So worst case scenario, I will do one in-person kind of like, you know, large quiz, and that will take up a lecture period if need be. But it will be of the same kind of magnitude and variety. And if I decide on that, I'll give you well advanced warning, at least 2 weeks. Okay. Because I understand how different this semester is, even the other semesters being different in other different ways. Okay. I know this is a lot of not learning right now. This is a lot of administrative, but I want to just say that I understand. Okay. So I've rambled on for 15 minutes, not actually teaching, but actually kind of describing it. So what is it that we are working with right now? We are working with a couple of big points right now. These are the kind of big picture things that we need to, that unfortunately, like everybody, that all come at once, because otherwise the questions I start asking get really boring, like ridiculously boring. So loops, functions, and sequences. That is what we are learning about. So we've already had kind of an introduction to loops, right? We've already had the introduction to loops. We did that with shapes and with turtles, right? A for loop specifically, for I in range, right, 5. This creates a range from 0 to 5, 0 up to, but not including 5, right? That was the language we used. And I simply takes on each of those values one at a time. Okay, and we run it, and we'll just simply get the values 0, 1, 2, 3, 4, 5. Oh, sorry, 0, 1, 2, 3, 4. We get 5 values. Okay, and this is useful for repeating things in a certain, that work off a certain number of, you know, work a certain number of times. So, but right now we've only been using the for loop in terms of going over a range. That in kind of actually leaves a lot to, that leaves a bit of questioning. Like, is there something else that for loops can go over? And the answer is yes, you can go over tons of stuff with a for loop. It isn't, the minute I fell in love with Python as a language was when I used a for loop to read over a file. And it was, again, it was not obvious. It was the least surprising use. That's what Python really tries to do. It tries to be as least surprising as possible. So one thing we can do in Python is for char in, and I couldn't say char in other languages because it's a reserved words in other language. For char in, let's go ahead and say word. The word is, hi there, my name is Andrew, all lowercase just for simplicity's sake. For char in, and I'm not going to call that word because that wasn't word, that's a bunch of text, right? That's not a word. Always name our variables something that makes sense, right? So for char in text. And if you're working from, and if you're coming from C or Java, this is gonna, if you haven't seen a for each loop yet, this is going to be radically different. Oh, sorry, for print I didn't define I, so silly me. Right? And you'll see that it said, vertically it's saying, hi there, my name is Andrew. What it's doing, in effect, is it's printing out each letter one at a time. So first off, what is char? It's short for, or care, because it's actually short for character. Character is kind of the name we give for any kind of glyph that the computer can write. And I would like to take the moment to remind you that your computer can write any glyph in any Unicode language. Unicode adaptability, which is to say computers not really didn't play well with other languages. It used to be the case. And now with Unicode, they do play well. So for instance, if I want to, just for the sake of it, again, I've done this example, but Japanese language, right? If I take Nihongo, which is the word for Japanese language, and I know very little Japanese, but I can recognize that specific sequence of glyphs. If I take that, paste that in, okay, notice it isn't really complaining at me. In about 20 years ago, this would have been a huge deal, okay? And also a huge deal that I could do this. I could print out each of those individual glyphs one at a time, okay? So if you're working, if you would prefer to work with characters of text in your native language, assuming English isn't your native language, go for it. I'm not going to complain. You know, it's there's no reason why you have to constrain yourself to English other than practice. You know, but all of these things are characters. Okay. So I'm going to just take this glyph. Okay. The single glyph. And I'm just going to kind of show there's a lot of abstraction that goes on here. So if I print, so what I can do, kind of show is that I can print I can use this inbuilt function. Ord gives me so what is ord? Ord is short for ordinal. It gives me so again, this is all zeros and ones, which means that these are all numbers under the hood, right? So this says, tell me what the number is under the hood, right? For instance, if I were to ask it for A, it's lowercase a, it should give me, I think, 97, I think. Yeah, 97 is lowercase a. I only know that off the top of my head because I have to use it a lot for cryptography kind of assignments. So if I'm using, again, this glyph over here, this glyph has the unique numeric value of 26,085. And I can kind of, and if you're curious and you want to play around, you can totally like do the reverse, which is with character, which is turn the thing into a character. So 26,086 will give me a different character, right? So now you don't have to worry. Now the reason I'm bringing it up is that there's a lot going on under the hood that you can peek under the hood, but Python just does a lot of the stuff automatically for you. Okay. So there's a lot of layers of abstraction, but Python especially is developed as a high level language that deals with a lot of these layers of abstraction and deals with them. And if there's similarities, they try to do this. So this text is called a string. It is a string is one of the two most kinds of sequences you will use. What is a sequence? It's what we use to denote anything that is a type that has more than one thing in it, right? A number like 13, that is a single thing, right? Yes, it's 13 ones added together, but it's just one data point, right? It's one single thing. Whereas this text is 3 separate glyphs, right? It's a sequence of 3 glyphs, one after another. If I change any one of the glyphs, it changes the meaning. It's a different sequence now. Right? Hello there. I can't resist, right? So if I say, so for instance, if I've got hello there, General Kenobi, that's a sequence of text. It's a sequence of letters, one at a time. HELLO, then a space. It's a sequence, one at a time. Now, if it's a sequence, we can iterate over it. Iterate meaning we can go over the thing one at a time. So for every character in the text, we print it out, right? It's nothing too exciting there. Similarly, so that is the first type of sequence we've been working with. There's the other type of sequence that we introduce in these chapters is called the list. Okay, because not everything is text. Sometimes we need to collect multiple data points, right? Let's see. So for instance, and I am opening my phone for a reason here. I'm opening my weather app. So low temps. Totally a reasonable use here. Low temperatures. Let's see. In Celsius, because that's shorter, 2, 4, -8, -7, -2, -7. So according to my phone, these are the upcoming low temperatures, right, for the next few days. Okay. This is also a sequence. A sequence, again, being a variable that holds a lot more than just one thing in it. Okay. Right. That's what a sequence is. And what's cool about sequences is that Python can automatically just iterate over them. Similarly, so similar to being able to just go over the text, we can, for temp in low temps, again, it doesn't really matter what I call the variable, but I'm calling it temp, in this case, short for temperature. Context helps us understand why we call it that. And I can totally print out the low temperature like this, print temp. And then I can print it out one at a time. If I wanted to find the average of these temperatures, right, I could do that fairly straightforward by saying, hey, let's create a accumulator pattern. So total is equal to 0. So just to recall, just to make sure, so I don't skip full ahead, how do you figure out the average of something, of a group of things? In this case, a sequence. You add them all together, and then you divide by the number of things you added together, right? You add them all together, and then we divide by the number of things we added together. So here I'm going to add all together using our accumulator pattern. Total is equal to the amount that we already had added together plus this latest number. Print total, and then divided by the number of things we had, and I'll just hard code that in for a second, which is 6, right? So the average low temperature for the next couple of days is going to be a chilly -3 degrees Celsius, right? I'm working in Celsius here because it gave me single digit numbers. So that laziness for the win, I guess. All right. One of the things though that's cool about Python is though, like I mentioned that basically it's hard for us to like kind of group certain beyond a certain point. It's hard to like tell at a glance how many members there are of a group or how many things there are. For instance, if I asked you to envision 5 apples, you can envision 5 apples pretty easily, like in your head, or 3 apples. But if I asked you to envision 11 apples, what are you most likely going to envision? You're not going to envision 11. You might envision a row of 6 plus a row of 5, or you might envision like in a, like you might with the face of a die, like 5 apples and then 2 3 bars, right? You're gonna think of the 11 as a composite of some numbers because it's just easier for our brain to do that. So similarly, like if I had a bunch of other numbers added into this, like I might have missed one, -8, -7. No, I didn't, but say that the next couple days are like this, right? Suddenly it becomes a lot harder for me to tell at a glance how many numbers I put in, right? And even if I count them, I'm a human, I'm imperfect, I might miscount. So let's not leave that up to humans. Let's leave that up to the computer to tell how big something is. So the way that it works for now in other languages, there's all like one of my biggest irks about Java is that if you want to know how big something is in Java, it depends on what it is. It's dot length without a parenthesis if it's an array, dot length with parentheses if it's a string, and dot size for everything else with parentheses. But for to tell how big anything is in Python, super easy. You just toss that thing in the length function. So pren len, that's the length function. That tells you how big something is. Returns the number of items in the container, like a sequence. Low temps. And now I will print out the upper number divided by the lower number. Makes sense to everybody? Not real, right? These are kind of the most, and it works for anything, by the way, I should mention. So here I'll be more grammatically correct. Hello there, General Kenobi, exclamation point, right? Star Wars prequels are underrated. And even if you don't think they're good, you need to admit that they are totally meme quality. So there you go. It's the hill I'll die on. All right, so length, text. So I can do that for text as well. So hello there, General Kenobi, with all the spaces and the exclamation point and the comma is 28 characters long. That's what that last one is. So we can, again, any sequence, if I just want to know how big it is, how many items are in it, no problem. I can do that. So sequence, so be it a list or a string, we interact with it in pretty much the same way. We can use length to figure out how big it is. We can use a for loop to iterate over how big it is. And we can do some really cool stuff with this now, by the way. Now that we have this kind of level of control, I can totally create so for instance, what I can do over here is I'm going to create I'm going to go ahead and just create a bunch of lines like this. So I can start up here. I'm going to go ahead and go all the way back to the top and import our good friend Turtle, just because I find that a lot of students, and I myself, like seeing pretty pictures to explain my things. So I've imported Turtle. I'm going to create a turtle. Bob is equal to turtle.turtle. That's our magic invocation to create a turtle. And now I'm going to go ahead and define colors. Colors is equal to, let's go with red, green, blue, and I'm going to go with pink, I think. I'm not going to go with yellow because yellow doesn't really show up too well on a white screen like this, okay? So here I've defined a list of words, a sequence of words. Now, it may give you some pause or some cause for alarm that you have a sequence. You might, if you step back to think for a second and go, wait, it's a sequence of sequences. Don't worry about that. These sequences are also, you know, their own items. But regardless, what we can do over here is iterate over it. So for instance, I can do Bob dot, I can do a for loop over here. So for each color in colors, and this is just a semantic thing, a grammatical thing I like to do, which is I like my sequences to be to be pluralized, and when I iterate over them, I use the singular word. It makes sense to me. This may horrify and disgust you. If so, feel free to use a different paradigm, okay? So you might prefer 4C in colors instead or something like that. So, but now what I can do, I can do Bob dot forward. So I can do Bob dot color to change his color into the color of choice. In fact, it may be actually at this point be better to deal with to change this to, let's see, to the color, just to be explicit. Bob dot color, change it to the color. Bob dot forward. Let's go with 50 just to start with, assuming I can type. So, and it's a bit hard to see, so let's go ahead and make Bob a bit bigger. Bob dot pen size equal to 2. Let's go ahead and it sometimes takes some experimentation, especially with screens like these. Let's see 7. That's probably extreme, but whatever. Oh, that's good. That's good. So I can kind of see that we've got we've got a nice train of color. Let's go ahead and up that to like 200. Right, make that nice and easy, big and obvious. It goes off the edge of the screen, whatever. Okay, because that's not going to matter for much now, because guess what my next step is? Bob dot Bob dot right is equal to 90. Right, so now I can make myself the thing. And again, yellow just doesn't show up nearly as well as those as these other kind of very strong colors going on over here. So now, of course, is where we can have, so now I can have some fun. Because one thing I can do is I can start by changing this angle to be ever so slightly off. Okay, which may mean, why in the world am I doing that? Well, now I've got a for loop. Here's the thing. There's nothing stopping me from throwing a for loop inside a for loop. Nothing at all. Which this is generally where people start having some issues, this understanding, but I'm going to try to explain as much as possible. A for loop can repeat anything, including other for loops. So if I write this, range 4, this means that this block of code over here is going to be repeated 4 times. And this is why I like turtles, because it's a very easy to see graphical example. So first I draw my first crooked, and then I draw my second crooked, and then my third crooked, and then my fourth crooked. Starts looking pretty cool, I think. Or even better yet, let's change, instead of dealing with angles like that, right? Right, if I do, let's go ahead and change it back to a square. 1, 2, 3, 4. Now, what he's doing is that basically he says, okay, repeat the following 4 times. Move forward as red, turn right. Move forward as green, turn right. Move forward as blue, turn right. Move forward as pink, turn right. And then do it again, the entire sequence again, because I told you to go over these colors again, okay? And now, what I could totally do is, remember, I've got a variable over here I can change. And what I'm going to do is I'm going to say basically, I want you to make your, let's see. let's see. Now, I won't go there yet. I've set it up wrong for that, so. Let's go ahead and keep with our crooked angles. So now that I've changed this to 87, right? Every time he goes around, the square isn't centered quite right, okay? Right, because I'm losing a bit. I'm not actually, he's turning 3 degrees less than he actually needs to. So at this point, I'm 12 degrees off of where I should be. Sorry. Each time he draws a square, he's 12 degrees off of where he should be. So he's done that 4 times. So he is 12 times 4. He is, sorry, 48 degrees off of where he should be. So that's pretty significant. So now let's go ahead and just keep going. 20 of these things. And let me go ahead and speed it up. Bob.speed is equal to 10 is about as fast. So it's 1 through 10 with 0 being instantaneous, but 10 being the fastest. So there, and we see we're kind of getting a really cool kind of spirograph kind of pattern just by changing the angle. And all I'm doing is just saying, hey, drop this off kilter square and then draw it again, and then draw it again, and then draw it again. And the reason it turns is because every time I stop drawing the square, I'm not returning precisely to the center because the angle is just slightly off. Okay, so we can, if I slow it down to a very slow speed now, you see that he turns a bit more, a bit less than he needs to, and when he returned over to here, he wasn't, when he stopped at that point, he wasn't at the point at which he needed to be. He hadn't gone back here. So now he's just slowly like drawing this thing where the lines are straight. Each line he draws is straight, but the angle is slightly off. So for loops can be used to repeat things that are for other for loops, which is really cool. And that is kind of the hardest thing that I find for you to work with, but don't worry, it helps when we kind of abstract it away and the like. And you're gonna have a couple weeks to work on this kind of concept, which is important. The idea of here nesting loops. Now that being said, we've been drawing shapes a lot. So one of the other things, and in fact, we repeat code a lot in this class. So the final thing that we're introducing here is the ability for us to, and again, this is all stuff I go over in the lecture videos, but I think it's important to go over it multiple times because again, this is where I see most of the students start struggling. And I feel like if I can give you if I focus my efforts here in trying to get you to understand this stuff, then the course goes much smoother, throughout the stuff. You don't have any big exams, but please focus on this assignment as much as you can and try to do it by yourself as much as you can, which is these exercises. So with programming languages, we repeat code a lot. And one thing we can do in programming languages is that we can, so what we've been doing is that we've been creating kind of new nouns throughout the language. Like we've been creating variables. We've been saying Bob is a new turtle and the like. But one thing but most of the time when we create stuff, we're going to be creating stuff via we're going to be creating new functions, new things that do stuff. We're going to be creating new verbs for this programming language. Here's an example. This is basically a simple example. Def shout it. Print shouty text, and I'm going to split up into a couple lines for you. Shouty text is equal to, and I capitalized it for the sake of humor. Shouty text is equal to text dot I believe in Python it is upper. Yes, text upper. And then print shouty text. Okay. So I'm going to do a show and then I'm going to tell. I'm going to show you what it does and then I'm going to tell you how it works. Okay. So I run it and it comes out in all caps. Hello, how are you doing today? Okay. So in other words, shouts it, as we've had to explain to, I'm sure, many a grandparent about their use of all capitals on Facebook, right? Right, so what is shout it? I've created a new command that exists while I'm running this program. So anytime I create a new command, it's stored in this Python file. It only exists in this Python file. So when I read it or I direct another Python file to read this Python file by importing, this command suddenly exists. So what does this command, this new command do? Well, the first thing you do or how does this work? Well, we define a new command by using this def word, which is short for define or define function. Okay, this def keyword shows up in a nice different color than everything else will. And then we name our function, right? If you're coming from another programming language like Java or C, you're going to be like, wait, where's the return types, or the visibility stuff? None of that in Python. You just tell me you're defining a function and give it a name. Okay, shout it. And then we take in one or more parameters. Okay. So for another example, def say hi it won't take any parameters in, and it will just simply say hi. Okay. It's one of those obvious things when you think about it, but you need to define a function before you use it, right? I can't say hi and then define it. I have to define what say hi is. See, hi, how are you doing today? So I have to define say hi before I can say it, before I can use it, right? Here I call say hi, but I hadn't defined it yet, right? In the code, it goes, because what it does is it reads through the code, comment, 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 comment. There's a command here that says say hi. What in the world is that? I don't know, crash the program, because it's not anything that's been defined. So before you use something, you have to define it. So what does this one do? It's say hi, it says, hey, I don't take in any parameters because what's between the parentheses is blank, okay? So the way you use me is by just saying my name and invoking me, right? To invoke, to cast the magic spell, I use the parentheses to say I'm invoking it. And then the colon to indicate that the following lines that are indented are part of this, which is just the print statement that says hi. Similarly, shout it takes in one variable. It takes in some kind of text. I can call it whatever I want. And then what it proceeds to do is that it proceeds to take the text, string. One of the things that a string methods of string has is upper, which does exactly what it says on the tin, which is that it creates a new string that is in uppercase. One thing that you'll see time and time again is that in pretty much every programming language is that strings are immutable, meaning you can't change what's inside a string. When you do kind of any operation on a string, the string will be, you're not actually going to be doing an operation on the string. You're going to be like creating new copies of it. So here you've got text to upper. We create a new uppercase copy of that, and then we print it. Say hi and shout, hello, how are you doing today? Okay, now the arguments are important here because if I try to say hi like this, right? It's going to say, hey, say hi takes 0 positional arguments, but 1 was given, right? It says, say hi doesn't take in any arguments, but you gave me an argument. You want an argument? I'm going to have an argument with you, Mr. Programmer, sir. No, bad joke. Okay. It's saying basically, though, that you are not correctly casting the magic spell. You are not using the new verb you created correctly. You're just supposed to call me and I do my thing. Similarly, if I do shout it without providing an argument for it, let me cut that so I can paste it in later. Cut, save, run. It's going to say, hey, it's missing 1 positional argument, right? You're supposed to give me a positional argument. You're supposed to give me an argument. You didn't give me any, and the one I'm missing is called text. So it probably has something to do with text. So now I can put something in. I thought it, okay. Don't know why that didn't work. Oh, because I'm not hitting control, that's why. And so if I try to give it like more than it needs, it's gonna tell me the same kind of thing. Hey, it's supposed to only take in 1 argument, but 2 were given, right? Now, yeah. Here's this another simple one. Def add, and we're going to take an A and B. Print A, comma, B, comma, A plus B. What is A plus B? It's just the sum, right? So here I'm going to give it 2 arguments. Add 7 plus 4, 7 comma 4. All right, this is a useless function because we already have the plus sign, right? But it's good for an illustrative purpose for a lot of reasons. Here I take in 2 arguments, 7 and 4. So print out 7, 4, and then the value of 7 plus 4. Now the question is, how did it decide which one goes into A and which one goes into B? Because it did decide. It said this is 7, this is 4, and this is 7 plus 4. Okay, how did it decide that? And the answer is the order in which you pass variables in is the order, is how it figures out what you want, right? So if I pass in a 7, it's going to copy that 7 over. If I pass in 4, it's going to copy that 4 over. Although, as you'll see, that copying is kind of both the truth and a horrible lie. So just be prepared to update your mental model eventually about that. So we did A plus B and then A plus B. Sorry, A, B, and A plus B. So 7 is A, 4 is B. If I do this order around, 4 and then 7, then A will be 4 and 7 and B will be 7, right? It's all based on the order in which you pass things in. Again, least surprising, it's kind of the least surprising behavior there. Okay, but surely we can do more than just simply shout words, right? Can we do something a bit more fun? Well, one of the things that I keep doing often, and I've coded a bunch of times in this class already, is drawing a square. So why don't we go ahead and create a function that just simply draws a square, so I'll have access to it a lot. All right, so I'm going to import turtle, and let's go ahead and uncomment out Bob, and we can increase the pen size and stuff like that. And now let's go ahead and create a function. Def draw square, and I'm just thinking for a second the best way to do it. The turtle, and then we want to draw a square. So what things do we need to know about drawing a square? We need the turtle that is going to do the drawing, because remember, even though you use one turtle, you draw multiple square. Even though you're using one turtle, you could have multiple turtles drawing stuff. By the way, hint for the Olympic rings. if you want the extra credit, try drawing it with 5 different turtles instead. Because the extra credit for the extra credit, I want you to overlap the rings exactly as seen in the drawing, right? The rings interlock one another. They don't just completely overlap the other, right? So try that with try doing that extra credit with 5 turtles, because if you've got them going in circles, you can just say, oh, I need you to go around the circle again up to this point. So anyway, so for drawing the square, we're going to need the turtle, and we want whoever we're going to be drawing with. Oh, sorry. We probably want, well, we know how many sides the square is going to have. So really what we're dictating is the size, which will be the size of the side, I guess. Okay. Now, how do we draw? And so the turtle is going to draw a square of this size. So, okay, we've drawn this enough time. The way to draw a square is we say for whatever in range 4, because the square has 4 sides, right? Let's say the turtle, because that's the name of the turtle right now. That's the variable that we're going to be referring to it in the function. And I chose this name deliberately. The turtle is going to be, we're going to want him to move forward some number of size, right? And then the turtle right, not size, but 90, right? They turn 90 degrees. All right, and I'm going to show, and that's really it. I'm going to show that this works. And for those of you who are thinking about what about return values because you read ahead or you have prior programming experience, then trust me when I say it's enough if you've seen return values before. If this is your first time seeing functions, we'll wait on return. Okay, there's more that functions can do, but we're going to wait on it. Okay, so now to draw the square, what we're going to say is just draw square, and we're going to provide it with the 2 variables it so desperately needs, which is we're going to provide it a turtle, Bob, and we're going to provide it as a size of some kind, let's say 100. And so now I run it. Oh, right, I still have the speed set to 1, so let's go ahead and comment that out. And there we go. And I'm going to prove that it's Bob, because what I'm going to do is I'm going to make Bob a different color. Bob dot color is equal to, we're going to set that equal to cyan. Nice bright blue color. Okay. And we see that that the turtle is Bob. But here I'm not saying Bob dot move forward. I'm saying the turtle dot move forward. So a way to think of this initially is that when we pass something into a function, something like a turtle, it's the same turtle. We're just kind of giving it a different name, a kind of temporary name tag for when he lives in this function. So essentially, Bob is putting on the name tag the turtle. Yes.
So when we've done turtles in the past, you assign the name and then do turtle.
Mm-hmm.
Where in the function does that come into play, or you just write that after?
I just did this to create a turtle. Here, we're saying there exists this thing called the turtle, right? There exists a turtle. Okay. It doesn't have to be created yet, but basically, this is going to act upon a turtle for some size. So the turtle doesn't have to be created yet, right?
Okay.
Like, is it bad coding practice to name the argument and the variable the same thing? No, it's not bad practice. In fact, I'll often just call this guy Bob, but I didn't want you to think that you had to match them, right? I didn't want you to have to presuppose that they had a match, right? You can call them whatever you want. And again, my videos go over this kind of stuff, but I'm just trying to show you what we're going to be working on and mastering over the next 2 weeks. What you're going to be mastering is the turtle and the for loops. The functions are just useful ways to, for at least right now, create multi-step programs for us. So because now that I've got this draw square, I can do some stuff with it. That's what really comes down to. I can do things like with this. For instance, I can say for I in range 10, I can say Bob, I can say draw a square, and then Bob dot, I can tell Bob to draw a square, and then I can tell him to move forward, let's say 10 pixels and draw another square, which is kind of boring for right now, but oops, what did I miss? Has no attribute forward. Forward. Right, apparently I can't spell, which is not too unsurprising. Give me 1 second, and I'm going to go ahead and speed this up considerably, because otherwise it will get very boring very quickly. So here, what am I doing? I'm telling him to move, I'm telling him to draw a square and then move forward 10 pixels. Draw a square, and the way I've been doing these polygons, if you remember, is that I make it so that the turtle always ends up where he started. And now we see why, because it makes me easy to kind of judge how these are going to go. Or better yet, so color is pretty interesting here. What is color anyway? Like that's both a philosophical question and a literal question. What is color? Yes. Did you define Bob over here? Because I've been commenting and uncommenting out code like crazy.
Yeah, I do have.
And did you import turtle?
Yeah.
Let's see, def draw, turtle at size. I'd have to see your code individually because trust me when I say it's very easy to make a mistake like that. So not quite sure what you mean by if it's an attribute. The turtle can take on 2 names. You can have multiple names for it. For instance, I can also say Bob can I can say also Bart is equal to Bob. And then I can say Bart, and these are both variables now that refer to the same turtle, the same guy. It's kind of confusing, but remember, you can have multiple names too, right? You have your name in class, you might have online usernames that you come up with, probably something cringy from high school that you thought was really clever and now totally regret, but now you're stuck with it. I'm not waxing philosophical about myself, no. So but going back to what I was saying, what is color? Okay. It's actually kind of a weird question because color is actually kind of complex. Best described by XKCD color. Color models. Let's see, is this one? Yeah, color is my evolution of color over time. Color is 3 primary colors mixed together. A rainbow, each color as a wavelength, unknowable. Maybe what I see as blue, you see as blank. 3-ish primary colors mixed together. RGB or RYB, red, yellow, blue, or red, green, blue, or cyan, magenta, yellow. A mix of infinite wavelengths filtered through 3 eye pigments, something about opponent color model, an abstract multidimensional gamut, an abstract multidimensional gamut filtered through inconsistently implemented device color properties, right? You may have noticed that what appears on your screen, the colors that appear on your screen don't necessarily match the colors that appear on other people's screens. In other words, watching a movie on your computer versus somebody else's computer can have a completely different shading and thereby impact your experience. And then you can see hyperdimensional 4-sided quantum Klein manifold. Is that a thing? hopefully somebody else's problem. So I like that one the best. But in general, the way that we deal with color, right, is that each pixel consists of 3 subpixels: a red light, a green light, and a blue light of differing intensities. Okay. And that intensity just kind of, again, differs over. And that intensity just differs between typically a value between 0 and 255. Why 255? That's 8 bits of intensity, which is a full byte. And that gives you quite a number of combinations, but fortunately, Python does it a bit differently with the turtles, which is nice. It just basically says, it gives you, we can define a color as being between some value between 0 and 1. So 0, 0, 0 for Bob is all black because the lights are turned off. Okay. So red, green, blue, where 1 means that the light is fully on at all intents. So there's red. And there is, and the second light on would be green. Okay. And then the third light would be blue, but let's go ahead and actually make this a bit more exciting. Let's fully turn on the red and the blue, and the blue light, and we get a purple, right? This is, by the way, a value between 0 and 1, not 0 or 1. So I can put in a half color and turn it on half the way, and we kind of get a more pinkish color than that's kind of a, on your over there, it even appears different over there. It's more pink, and over here it looks like more of a dark red, right? So, but this is a color that can be changed over time. So like, for instance, here I've got I in range 10. So what I could totally do something like this. Bob dot color, okay, and then I can say I 0, 0, 0, because those are our 3 colors, right, all turned off. And I can do I could do 0 plus I times 0.1. Why 0.1? Because we're doing a 10. Actually, I'll just do, yeah, I'll just copy this. So 1/10 of the I value, because remember, I is going to be 0, then it's going to be 1, then it's going to be 2, then it's going to be 3, then it's going to be 4. By multiplying it by 1/10, these values are going to be a 0, a 10th, a 20th, a 30th, a 40th, a 50th, a 60th, or 0.6, 0.7. They're not a 10th, then a 5th, and so on and so forth. And you notice that as the lights get on, it's moving through different grayscale kind of stuff, which produces a cool animation, right? We did one black circle, then we did a slightly lighter circle, and then a slightly lighter square, then a slightly lighter square, and then a lighter, until it got continuously lighter. But that's kind of boring and not very colorful. We don't live in a world of grays. We live in a world of vibrant colors. Again, let's turn off the green light and just turn on the other lights slowly. So here, I'm slowly turning on the red and the blue light. And we see that we slowly progress from a black to a purple. It may be more easy to see if I put some distance between stuff. So let's go ahead, make our circle smaller. Sorry, let's make our square smaller, and let's go ahead and move forward. We'll go ahead and move forward 60 squares between each of them. So now that I put some space between them, we can see the kind of the gradation between it a bit more strong. Now that but again, we're starting out with black, which isn't particularly colorful. So here's what I'm going to do. I'm going to kind of flip this around. Let's start with the blue being on, but the red being off. And then we'll slowly subtract the amount of blue there is. minus I times 0.1, because again, the 0.1 is just so because this is going to be from 0 to 10. We want a value that's going to be less than 1 all the time. So here, we're shifting from reds to blues. It's pretty cool, to be honest. I like that. It's pretty cool. All right. So enough of you have stuck around long enough that I think it's time to reward you with a tidbit for paying attention to me.
Can I ask a question first?
Yes.
What does the I for I in range mean again?
So that's the variable that goes that represents each of the values in the range. So the question is, what is the I in the 4i in range? Again, and the answer is range gives me all these values. It gives me, because it's range 10, we're going 0, 1, 2, 3. We're going over all these values. All the values up to, but not including 10, okay? So I is each of those numbers in turn. Does that make sense?
Yeah.
Okay, so let's talk about, let's see, it's week 4, so appropriate time to talk about the final exam, right? The final exam consists of 3 questions. Question 2 is a turtle question. And it will be simple, and it's fairly simple and straightforward, which is that I give you a bunch of code. And I'll ask that will produce a complex geometric pattern as its output. But I'll ask you, what do each of these components do of the code? Read through this code, tells me what it does. What does this function do? For instance, I might have a function that looks like that kind of looks like this. For instance, on the exam, if this were the question, or if this were part of the question, I might obfuscate it like this. Ignored. Right, and I might just simply replace everything. And I'm not going to necessarily make it too terrible, but I will make it something like this, where the meaning is no longer super obvious, and you have to like, oh right, this is if I follow this out, and I might put down, like I might have in a comment, Gazorp is a turtle, right, for you, just to make sure that you know, and so over here you got to figure out, okay, what does this function do? Oh, this function draws a square. And this is being called by another function that draws a complex kind of spiral pattern. So so basically explain through the code. So mastering the turtles and the for loops, that's basically 1/3 of your final exam. So worth.
You have more than one turtle?
What? Yep, you can totally have more than one turtle. You can totally have more, you can have multiple turtles. Generally, I like my turtle problems to just have one turtle. I'm not going to be like having a bunch of turtles all going around. That's because I've got to be able to write these things and trying to keep track of more than one turtle. I mean, gosh, that seems horrifying. So, but actually using more than one turtle is kind of useful sometimes, as I've mentioned, for the extra credit in lab 3. If you try to do it with 5 turtles, each drawing one of the separate rings, you might find you'll have an easier time not only doing the problem, but doing the extra credit of the problem, because then you don't have to try to move that single turtle all over the place to fix the problems. Yes. Yep. Yep, it's just slight variation of color. So what is going on here? Right, the first time we go through, let's see, so sorry, I accidentally just hit 5 when I meant to hit F5. So what's going on is that during the first loop, I is equal to 0, okay? What's going on is that during the, and let me go ahead and get a pen, so let's see, sorry, I've got to move all, here we go, pen. Okay, so during this first circle over here, during this first circle, I is equal to 0, Okay, the first square, I is equal to 0. That's because, and so as a result, the color is going to be 0 plus 0 times 1/10, because that's what we've got over here. That's, times 0.1, which comes out, then we've got a 0 for the second argument, and then we've got 1 minus I times 0.1 for the third argument. I over here is also 0, which means this entire thing becomes 0. How am I trying to do this with my mouse? Oh my gosh. Dear me. Right, so in other words, for the first square over here, we essentially got 0, 0, and then 1, because we had 1 minus a bunch of stuff. So that's what, so the third argument is the blue light. The blue light is turned on, but nothing else is. I realize I may have just jumped that because nobody was asking questions. I just kind of blindly charged forward, and I realize my mistake now. Let's go ahead and check number 2. Sorry, the second part, which is 1. So this square, I is equal to 1. And you'll notice that it's just a shade changed. That's because we've got, with I as being equal to 1, we had the following. We had this in color. We had 0 plus 1, because, so we had 0 plus I, except I is 1 now, times 0.1. So in other words, 0 plus 0.1. Then we had 0 plus 1 minus 1 times, 1 times 0.1, which becomes again 0.1. So this entire thing becomes 0.1 with a little bit of red. So we turned on the red a little bit. There's never gonna be any green because it's always 0. And now this is a little less blue, 0.9 blue out of 1. Okay. Now the next, so when I is equal to 2, we'll do 2 times 0.1, which is gonna be 2 over here. Then it's gonna be 1 minus 2 times 0.1, right, which is going to be 0.2. So that becomes so this becomes 0.2. So this is 1 minus 0.2, which becomes, this becomes 0.2, 0, 0.8. So, and we see that kind of reflected, that the third square over there, where I is equal to 2, 0, 1, 2, where I is equal to 2, we see that this guy is just got a slight bit of red added and a bit of the blue turned off. Does that make sense? And this just continues on in this vein until we get to, 1 second. And then it continues on in this vein until we get all the way to the end where I is equal to 9. Okay, I is equal to 9. So the color was 0 plus 1 times 9, 0. And then I had 1 minus, because I started with this, with the blue being on and I was turning it off slightly. That's why I did the 1 minus. I times 1, which became, and I was 9, so this became 0.9. So in total, this becomes turn on the red almost completely and only have 1/10 of the blue, right? So we were slowly changing it with each step. Yes.
Does it go all the way up to 1 or is it 55?
Excellent question. So the default mode is to go between 0 and 1. Okay, you can change it to go between 0 and 255 if you want it to. You can set the color mode to say, hey, I want colors instead of being between 0 and 1. It can be between 0 and 255. It's a function for turtles to how it accepts colors. Okay, it's here. It's a function, I believe, called color mode. Clear all drawings. Now, if this seemed like a lot, by the way, before you get completely freaked out, what have I said? This is what we're doing over the next 2 weeks. All of this. All this is over the next 2 weeks. So, and before you all run away, I see you edging to get out of class, right? So color mode over here, right? You can change it to 1. And then here, if you try to change the color. So this is the default way, 1. If you try to change the color to be out of range of 1, it will yell at you. But if you say, hey, set the color mode to 255, then you can have it however you want, you know, between those classical values. So, all right. So again, about this assignment, let me just pull up the assignment that we've got here. And by the way, I'm going to be importing your grades into Canvas this week. So the ones from Runestone. So wait for an announcement. So look for an announcement from that. But anyway, this for loops assignment. Okay. Let me open it up so that I can see it easier. Here we go. Right. I have some advice and stuff on how to do this. I'll probably have to fix this link, but I have a bit more advice on how to use for loops. You had a question? No, you don't have to have the top be in for loops. So it's a bunch of different, it's 9 separate small problems, such as printing out the song 99 bottles of beer using for loops or creating a multiplication table. So the first 3 are going to be standard, or basically kind of standard questions you'll see in most classes, just kind of to deal with for loops. Your next questions are basically doing what I did today. I actually just did this one in class for you. Draw square. Then the next one is drawing a row of squares. Then drawing a grid. And then drawing some stairs. Creating a function that will draw a polygon. And then create something that creates something like this, which looks horrifying, but it's actually not. It's actually turtles are actually really good at just creating a couple of commands and giving something like this. It's not nearly as scary as it seems for that last one. It seems like it's a huge jump from this to this, but it's not, because if you trace the lines carefully, you'll see that this is just a bunch of the same shape drawn over and over again and just slightly turned each time. And then there's 5 bonus questions, each worth 5 points. And the big thing for each of these, this one, the draw stairs, draw squares, draw a grid, because you're doing them as functions, each of them can call the previous function you wrote. For instance, drawing a row of squares, you should totally call the draw square function you just wrote. Similarly, if you're drawing a grid is a bunch of rows, which will in turn call draw squares. This will become more apparent to you as you work through the readings and as you work through the exercises. All right, so that is all for today. You are free. We will do an exercise on random password generation next class.
I think that's it.